So this is the 56th video on Newton's laws of motion. This is in continuation of the 55th video. So in this video I'll take another numerical problem involving Newton's laws of motion and constraint theory, with the only difference that now all the pulleys will no longer be assumed to be massless. Till now we have assumed that all the moving pulleys are massless. Till now we have assumed this. But in this video I'll drop this restriction that all the moving pulleys are massless. Okay, so that is some movable pulleys also there. Alright, fine. So I'll first write down the question. Fine. See, the problem is this. This is a fixed ceiling. Okay. This is a inextensible string. A fixed pulley is here. From this pulley, string is wound on this pulley. This is an inextensible string. Is attached to this pulley. Center of the pulley it is attached. And here string is passes over this pulley. And two blocks are connected here. Okay. Suppose mass of this block is 1 kg. And mass of this block is 2 kg. Assume mass of this pulley to be say 5 kg. And suppose a block is attached here. Mass of this block is say 10 kg. This is the diagram of the situation. This is one string S1, this one. This is another string S2, this one. This is another string S3. Alright, fine. Now, the strings S1, S2, S3 are all massless, inextensible, and there is no friction between string and pulley anywhere. All the pulleys are massless, okay, and uniform pulley, that is center of mass is at the geometric center. Now, system is released from rest, okay. You have to find the acceleration of the 1 kg block with respect to ground, magnitude and direction both. So find the acceleration of 1 kg block with respect to ground after the system is released from rest. Kg block with respect to ground after the system is released from rest. Okay. Answer should be in terms of G. Acceleration due to gravity. Alright. So now, first, what do we do first? First, we show the tensions. This string S1 is massless. And there is no friction between string S1 and the pulley in contact. So tension at all points of this string is same. T say. Now this movable pulley has a mass. So we can't write tension S2 as 2T. So we write it something else. Again, S2 is massless. And there is no friction between S2 and this pulley in contact. So tension at all points of the string is same. But as just said, we can't write it as 2T because this pulley is moving. It has a non-ignorable mass. So we write it as T1. The tension throughout this point is everywhere T1. And this tension, what you write, you want to write it T2, right? Because that will not be used. So it's no use there. But you write it whatever it is. Alright, fine. Now I draw the free body of these three blocks and pulleys separately with respect to ground. Okay. So I draw the free body of this block here itself. 1G, weight. T upward. I show the accelerations also. Suppose I assume that this accelerates A with respect to ground in upward direction. Suppose this accelerates with B with respect to ground in downward direction, assumed arbitrarily. Suppose the pulley accelerates, suppose I assume that this 10 kg accelerates with downward C with respect to ground. Now one thing, see, you can see that this pulley is fixed and this string is inextensible. So acceleration of this pulley and this block will be equal in magnitude and they will have opposite directions. I hope you are understanding what I am saying. This pulley is fixed and this string is inextensible. So this pulley and this block will have identical acceleration in magnitude but in opposite direction. So if this goes down with C, then this will move up with acceleration C. But still, I would like to prove it formally from the constraint theory. So I am assuming that this pulley has an acceleration of say W with respect to ground. Okay, W is the acceleration of pulley with respect to ground. Okay, I am not writing as P, I am writing as W. W doesn't mean wedge. It just means acceleration of pulley, this pulley with respect to ground. Okay. I'll prove that W is equal to C indeed. It has to be, I suppose, but this I'll prove it separately from the constraint theory. Alright. Now I draw the free body of this 10 kg. So 10G and T1 up. Okay. Now I draw the free body of this 5 kg pulley. I draw it here separately. So weight of 5G acts at its center, effectively center of mass. Okay. Now this string exerts this string which is folded on this pulley exerts a force T and T at these two ends effectively. As I have been discussing such problems many times. So one T acts here, one T also acts here. Now this string S2 is attached to center of the pulley, so it exerts a force T1 in upward direction. Okay. So all the free bodies with respect to ground have been drawn. Fine. Now love this one, okay. Now write down the Newton's law equation for each body with respect to ground along directions of the respective accelerations. First I write for 1 kg block, T up, G down. So T minus G equal to 1A. T minus G equal to A. First equation. Now write down the Newton's law equation for 2 kg block with respect to ground. 2G down and T up. So 2G minus T equal to 2B. 2G minus T is equal to 2B. Second equation. Alright. Now write down the Newton's law equation for 10 kg block with respect to ground. It has been shown to accelerate downward with C. So 10G minus T1 is equal to 10C. 10G minus T1, 10C. This is the third equation. 10G minus T1 is equal to what? 10C. Fine. Now write down Newton's law equation for pulley in upward direction. This I have shown arbitrarily in upward direction. Okay. So what will write? T1 minus 2T minus 5G equal to 5W. Fourth equation. Alright, fine. Now see, count the number of unknowns. How many unknowns are there in the problem? You can see how many unknowns are there. A, B, C, W, 4 and T1. 6 unknowns are there. So we need a total of 6 equations. But 4 equations we have already written from Newton's law. So remaining 2 equations will come from the constraint theory. What is that constraint theory going to be? Now see, in this case, the non-movable pulley has a non-zero mass. So we also have to take into account work done by string on these two pulleys. So now in this case, you must recall, you must go to the 32nd and 33rd videos of the constraint theory. From that you will get the constraint relation for in this case. But still, in view of its importance, I will repeat that part here itself. Whatever I have said already in 32nd and 33rd video, part of it I will repeat it here so that you don't have any further doubts. Okay. Or I'll write it the result directly. Okay. What should I do? Should I write it or should I explain it? What should I do? See, I'll just explain it again. Again, go back to the basics. See, this string S1 is of constant length. Work done by S1 on this plus this adds up to 0. Okay. So let's call this as block as B1. Let's call this block as B2. Let's call this block as B3. And let's call this pulley as P1. Okay. So because length of string S1 is constant, see this I have already derived. I have discussed it already in the 32nd and 33rd video on Newton's laws. But still I am repeating it here, but just for the view of its importance. Okay. If you go there also you get all the details. If you go to the 32nd and 33rd video. But still I am repeating it here just so that you don't have to go there. You can directly see from this itself. So what do we write? C. We will go back to the basic. Since length of string S1 is constant, work done by S1 on all bodies in contact with it adds up to 0. So this S1 is in contact with this block B2. It passes over this pulley P1 and is in contact with block B1. So work done by S1 on these 3 bodies total adds up to 0. Work done by S1 on B1 plus work done by S1 on B2, work done by S1 on P1 adds up to 0. Now repeat the same thing for the string S2. Here we are writing the constraint equation in ground frame. All the work done have to be taken with respect to ground frame. Now take string S2. S2 is of constant length. So work done by S2 on all bodies in contact with it adds up to 0 in any frame or reference. So S2 is in contact with this pulley P1 at this point. It passes over this pulley and it is in contact with this block B3. So work done by S2 on this and this adds up to 0 in any frame or reference. In ground frame we are using in this case. So what do you write here? Work done by S2 on B3 plus work done by S2 on pulley P1 plus work done by S2 on what? This pulley P2, which is fixed in ground frame. 0. Now this is separately 0 because this pulley is fixed in ground frame. Pulley does 0 work, this string S2 does 0 work on this pulley P2. Now what we do, we add these two now. We add these two equations. So what do we get? See, here these two will not add up to 0. We add these two constraint relations. Work done by S2 on I'll just repeat it here. Okay, I'm very sorry. This is not 0, sorry. This is not 0, by mistake it was written that. 0 is this. This is 0, S2P3 is 0. In fact, S2P2 it is. Okay, I just repeat it. Here, okay. I'll write it down once again. Just to avoid the confusion. So this I wrote for S1. Work done by S1 on B1 plus work done by S1 on B2 plus work done by S1 on P1 adds up to 0. Now repeat the same thing for string S2. Work done by S2 on P1 plus work done by S2 on P2 plus work done by S2 on this block B3 adds up to 0 in any frame of reference. But here we are applying the constraint theory in ground frame. In ground frame, pulley P2 is fixed. So S2 will do 0 work on this pulley P2. So this term goes away. Okay. Now what I do, add these two equations. So if I add these two equations, what do we get? This plus this plus this. Work done by S1 on B2 plus work done by S2 on B3 plus these two terms. Work done by S1 on P1, work done by S2 on P1 adds up to 0. Okay. See, if this pulley was massless, P1, then here TT, then T1, this tension will be 2T. Then this plus this would add up to 0. I hope आप समझ रहे हैं क्या बोल रहे हैं. अगर ये पुली मास्टर्स होता 5 kg नहीं होकर 0 kg का रहता, यहाँ T1 को what will write as T1 2T. Then this and this will add up to total 0 work on this pulley P1, and sum of these two will become 0. But since the mass of this pulley cannot be ignored, it's 5 kg. So the tension, this string cannot be written as 2T. It is something other T1. So here these two will not add up to 0. I hope it is clear what I have said. Fine. All right. So this is the constraint relation which you are going to get now. So see. Now in this you can see that suppose this block gets displaced by dy1 in ground frame. This gets displaced by dy2 in ground frame. This gets displaced in dy3 with respect to ground frame. And this gets displaced by dy with respect to ground frame, pulley P1. Okay. So work done by S1 on B1. B1 is what? This one. T up, dy1 also up. One more thing. See, I have assumed that acceleration of 1 kg is A up. So if it is released from rest, it will move in the direction of its acceleration. So I have taken dy1 to be in upward direction. Alright. So work done by string S1 on B1. T dy1 cos 0 degree. T dot dy1. So T dy1 cos 0 degree. Alright. Plus work done by string S1 on B2. B2 dy2 is displaced downward. T is up. Minus plus T dy2 cos 180 degree, which is minus 1. Plus work done by S2 on B3. The B3 I have shown to accelerate downward C, so it gets displaced also in downward direction because it is released from rest. So T on upward and dy3 down. Angle becomes angle be 180 degree between these two vectors. So it becomes T1 dy3 cos 180 degree, which is simply minus 1. Now this term also remains here, which I have said just now. Work done by string on pulley P1 plus work done by string S2 on pulley P1, that also we have to take into account. Now see, this pulley S1 exerts force on this pulley P1 at 2 points. T like this, T like this, effectively. And this string S2 exerts a force on this pulley T1 in upward direction. And this pulley I have assumed to displace by dy amount in ground frame. Alright. Now what I'll do, I'll include this work done also. Plus 2t work done by S1 on this pulley P1. 2t down, dy up. 2t dy cos 180 degree, which is minus 1. Here T1 up, work done by S2 on this pulley P1. T1 up, dy up. Angle between the force and displacement is 0 degree. T1 dy cos 0 degree. This all add up to how much? 0. I hope it is clear what I am saying. Okay, fine. Alright. On this I'll rub this one. So now what do we get? See, dy1 is here. Okay, fine. So what do we get? T I take common in this term. This I take t common. How much t will become? dy1 minus dy2 minus 2 dy. Okay, fine. And t1 I take common here. Minus dy3 is equal to 0. See, this is the constraint relation which you are going to get. This is the fifth equation. Now one thing I would like to say, see, tension cannot be a negative quantity. Tension in a string will either be 0 or more than 0. It cannot be a negative quantity. So this equation is going to be valid for all values of t and t1 more than or equal to 0. Now I love this one, okay, fine. Okay, let it remain, okay. Okay, fine. I love this one, okay, fine. So this equation is constraint relation is valid for all t and t1 more than or equal to 0. Since it is valid for all non-zero values of t and t1, so this equation can be valid only when coefficient of t and t1 separately vanish. So this equation can be satisfied for all non-zero values, non-negative values of t and t1 only when coefficients of t and t1 separately vanish. Of t and t1 separately vanish. So coefficient of t is 0. This is the coefficient of t. So dy minus dy1 minus dy2 minus 2 dy is 0. Alright. So this means dy1 minus dy2 equal to 2 dy. Now here there are no variable angles in the problem. So constraint relation for displacement and acceleration will have the same format. So replace dy1, dy2 and dy by the corresponding accelerations. So this becomes A, this becomes B, and this becomes W. Okay. So one relation we have obtained, fourth relation also we have obtained C. This also we have obtained. And here see, coefficient of T1 also 0. Coefficient of T1 0 meaning dy minus dy3 0. Dy minus dy3 is also what? 0. So now replace dy by corresponding acceleration W is equal to, and replace dy3 by what? Simply C. See, W and C have been proved to be equal. This is what I said in the beginning. Since the pulley, since the upper pulley which is attached to ceiling, that is fixed, and the string is inextensible, so acceleration of pulley P1 and block B3 will have equal magnitude but in opposite direction. So see, with that this I proved it separately also from this equation. Alright, this I proved it separately from this equation. I proved W is equal to how much? C. So now we get A minus B equal to 2W and W equal to C. That meaning A minus B equal to 2C. So this is the fourth equation. This is the next equation, last equation. Okay. So now what I'll do, I'll write down all these equations and then solve them. I love this one, okay. So A minus B equal to 2C. This is the last equation. Okay, fine. Alright. So this is the last equation. So now all we have to do is to solve such equations. That's all. So if A becomes T minus G, B becomes G minus T by 2. And if we add these two equations, T1 goes away. Adding fourth plus third equation, what do we get? T1 goes away. 10G minus 2T minus 5G is equal to 10C plus 5W. W is equal to C. So this becomes 5C. So we get 10G minus 5G becomes 5G minus 2T equal to 15C. So 5G minus 2T is equal to what? 5G minus 2T becomes equal to 15C. Now let's substitute in this equation. A becomes T minus G. B becomes what? G minus T by 2. We divide this by 2. G minus T by 2. 2C. Now C we divide this by 15. 5G by 15 becomes G by 3 minus 2T by 15. See. Okay. Now see you can get T easily from this. And we rub this one, okay? Now simplify this T and bring T on one side. 1 plus minus plus half plus 4 by 15 equal to, I take G on that side, 2G by 3 plus G, 2G. So T into, it becomes what? 3 by 2 plus 4 by 15, 8G by 3. This becomes 45 plus 8, 53 by 30, 8G by 3. It becomes 80G by 53. See one answer, we have 10T. All you have to do is substitute in these equations to get A, B, C and W. C and W are equal, that is already true. A, B, C only you have to find. So we substitute T here. A becomes T minus G. 80G by 53 minus G. This becomes 27G by 53. One answer we have obtained. We obtained a positive, meaning direction of A which we have assumed upward is correct. Now B, what we have to do? We get B from this. I love this one, okay? Now B from this equation is what? G minus T by 2. Now T by 2 is what? 40G by 53. 40G by 53, that is 13G by 53. This is answer to part B of the question. B, expression of the right side to the 2 kg block. And C is found from this. A minus B by 2. The A is 27G by 53. 27G by 53 minus B. B is how much? 13G by 53 upon 2. 27 plus 13 becomes what? 14. 14 by 2 becomes 7. 7G by 53. This is the expression of this 10 kg block with respect to ground. And expression of pulley P1 with respect to ground is same as C. That is just 7G by 53. That is therefore the required answer. Is it fine? Alright. Here. This also I have demonstrated. So this question also I have demonstrated all the essential concepts. For the case when the pulleys, all the movable pulleys do not have zero mass, we cannot ignore the mass. In that case, how to write down the constraint equation that I have said here. I already repeated that if you go to those 32nd, 33rd video, you will get the details. But in view of this importance, I have stated here also I have written down the basic theory, constraint theory. Okay, so go through it properly. If you have any doubt, write down in the comment box, I'll clarify it. If you have some doubt, you go through these videos repeatedly, you go through the videos. Then if you repeatedly go through videos, then all your doubts will be clarified. But still, if you have some doubt, you write it in the comment box, I'll clarify. Okay, so this I close it now.